All right, also 7.3 deals with imaginary numbers. All right, y'all. So if y'all recall, in our last section, when we tried to take the square root of a negative number, we said that this was not real. But they wanted to be able to work with these kind of numbers. So they came up with what we call imaginary numbers. So what we did, we're going to define the square root of -1 equal to I. Okay, so when you see this I, it's really a square root of -1. But what that does is it lets me play with these kind of radicals where we couldn't get answers out of them before. So what we would do on this, for that square root of -4, we would break this into a square root of 4 times a square root of -1. So now we're able to take the square root of 4, which give us 2. And remember, that could be positive or -2, because remember, square root of 4 could be -2 also, but we'll just deal with what we call the principal square roots here. Now, we still can't take the square root of -1, but we will replace it with I. So this tells me that in the real world, I cannot take the square root of -4, but I can in the imaginary world, okay? So when you see something like 2y, that means they took the square root of a -4 to get that. So let's look at some examples real quick. And these will say express in terms of I. Now, we'll show you real quick. If you want to be able to do these on your calculator, I'm going to share my screen real quick. Now, remember, on the calculator, if you tried to take the square root of that -4, remember, it's going to give you an error message and say that's a non-real answer. So what we want to do, if we want the calculator to take square roots of these negative numbers, we got to change the mode. So right here by the blue button on top, you see mode. Push that mode button, and then you're going to arrow down to where it says real. So remember, we're in the real right now, but I'm going to arrow right and highlight A plus BI. Highlight A plus BI and hit enter. Now it's highlighted the A plus BI. And y'all, that stands for complex numbers, which are imaginary numbers, okay? So once you got the A plus BI highlighted and you hit clear, now when I try to take the square root of that -4, so let me put in my -4. Now when I take the square root of -4, I will get the imaginary answer of a 2y. So the calculator will knock these out if they're perfect squares, okay? Now, some of these they're giving us are not perfect squares. So let me show you what we'll do on those. So let me go back to my page. So I'm going to express in terms of I. So y'all, number one, they're giving me a square root of -17. Now, if it'll give you the I on the calculator, but it's going to give you a decimal approximation. But y'all, all we got to do on this one, since 17 doesn't break down into any perfect squares, all I'm going to do is bring out my 17 and my -1. Now, we cannot simplify the square root of 17, so we'll bring that down. But remember, the square root of -1 equals I. Now, when you write this answer in, make sure you arrow out from under the radical before you put the I. The I cannot end up under that radical. So a lot of times when I got this type of answer, I'll put the I first and then my square root of 17, okay? Same thing with number 2. I got a square root of negative 7. Let's break that apart into a square root of 7 and a square root of negative 1. Now remember, my perfect squares I gave y'all the other day, 4, 9, 16, and so on. None of those perfect squares are a factor of that 7, so that means the 7 will not simplify. So I'm going to bring down that square root of 7. But the square root of negative 1, although I can't take the square root of negative 1, I got to replace it with the I. So I might write that as what, an I square root of 7 in math lab so that it don't look like the I is under the radical. So basically, if you notice, all we're doing, bringing that negative out and making it an I, okay? Now this one's square root of negative 144. Remember, 144 was one of our perfect squares. So this one could be done on the calculator. But what I would do is I'd make that a 144 and then a square root of negative 1. Square root of 144 would give us 12. And then the square root of negative 1 we replace with our I. So they're pretty much like the square roots we were doing the other last week. It's just we're now taking care of that negative by using the I, okay? Same thing here, square root of negative 36. And then the I is letting us know that we couldn't do this in the real world, but we can do this with imaginary numbers, okay? So 36 is a perfect square. So I'm going to make that a square root of 36 times the square root of negative 1. Square root of 36 is 6. And then we'll replace the square root of negative 1 with our I. All right, now watch out when I put a negative out front. So let's do a negative square root negative 5. This negative is not affected by the radical. So no matter what, you would bring that negative down. And then we're going to play with this square root of negative 5. We're going to break out that negative 1 by making this a square root of 5 and a square root of negative 1. So if you notice, this answer will stay negative. Anytime you got a negative in front of a square root, that answer will stay negative, okay? So I'm going to bring down the negative. Can't do nothing with that square root of 5 because it's not got a square root. But then I can replace the square root of negative 1 with my I. So to get this where it don't look like my i's under the radical, I'll probably write this as a negative I square root of 5. So notice, this is one of those cases where a negative and a negative does not make this a positive, okay? Because this negative is not under those radicals. Well, y'all, same thing on this one. Negative square root of negative 2. Once again, bring down that negative. We'll break down the square root of negative 2 as a square root of 2 times a square root of negative 1. So it looks like it's going to happen the same thing I had here. I'm going to bring down that negative. Can't do nothing with the square root of 2. But I can replace the square root of negative 1 with I. So I'm going to write that as a negative I square root of 2. So if you got perfect squares like 36 and 144 under the radical, it will come out as a number. If you got numbers that are not perfect squares like 5, 2, 17, and 7, they're going to stay under the radicals. All you're basically doing is bringing that negative out as an I. So y'all, negative square root, negative 49. So if you notice, I'm going to keep bringing that negative on the outside down. I'll make this a 49 times -1. Once again, bring that negative down. This time, 49 does have a square root of 7. And then square root of -1, I'll replace with I. Now, we're not able to take square root of -1. We're just replacing it with an I. So anytime you see these I's, remember that I is really a square root of -1. We're just using what we call shorthand for it, okay? All right, y'all, 8 was the same thing, a negative square root, -36. Once again, I'll bring that negative down. I'll rewrite this as 36 and then -1. So remember, 36 is a perfect square, so I'm going to bring down that negative. Square root of 36 is 6, and then replace that square root of -1 with the I. Now, y'all, the ones that are perfect square roots like this one, we can do on the calculator. So let me pull that up. So I had a negative square root of a -36. Now, the perfect squares it will do, and it'll give me my -6i like I needed, okay? The ones that cannot do are like that -2 I did. Let me show you. If I did a negative square root of a -2, the calculator is going to turn those into decimals, which are not what we want on these, okay? So perfect squares, fine to use the calculator on. If it's not a perfect square, you just got to keep that number under that radical. And then notice, none of these numbers I've been playing with so far, like the 7, 17, 5, and 2, none of those had any factors that were perfect squares. So let's see some of these where you can simplify them. So we're still going to express these in terms of I, but I'm going to do a square root of a -18. And I'm going to write my perfect squares over here again. 4, 9, 16, 25. What's next? 36. 7 times 7. 8 times 8. 9 times 9. 10 times 10. 11 times 11. 12 times 12. 13 times 13. 14 times 14. And then 15 times 15. So I'll go up to 15, okay? So remember, if these numbers under the radical have any of these perfect squares as factors, we got to break those down. So what I'm going to do on this one, since I know 9 is a perfect factor, I'm going to make this into 3 radicals. I'm going to put my 9 in, my 2, and then my -1. So if you multiply all these together, you get a -18. So y'all, here we go. We pulled out that 9 because it has a square root of 3. So bring down to 3. Can't do nothing with the square root of 2, so it stays under the radical. But then the square root of -1 is an I. So the way I write this one in MATLAB, I would write my 3, then my I, then my square root of 2. Always keep the radical stuff at the back of it, okay? That way it don't look like anything else is under that radical. Same thing with -50. I know I'm going to break out that -1, but I'm trying to see if any of these factors are factors of 50. And I do have a factor of 50 in that 25. So I'm going to break this down as a 25, 2, and a -1. So let's see what happens. Square root of 25 is 5. Once again, can't do nothing with that square root of 2, so I'm going to bring that down. And then I'm going to replace the square root of -1 with my I. So in math lab, I'd probably write that 5I square root of 2. Now, it will take it this away. Just make sure you arrow out from under that radical before you put the I, okay? All right, so y'all, that's the trick on those. Those negatives are coming out basically as the I. And then you're going to simplify the radical just like you did last week. So now we're going to look at some operations on these. We're going to look at adding and subtracting and then multiplying, okay? So when adding or subtracting, it's just like terms. The real part adds to real. So the real part adds to real, and imaginary adds to imaginary. So these together are what we call complex numbers. So let me explain those to you. Complex numbers come in the form of A plus B I. A is the real part. This BI is what we call the imaginary part. Okay? So we usually put these in parentheses when we're doing operations on them. But just remember, real numbers add to real numbers, imaginary numbers add to imaginary numbers. So let's see. It looks like I got 2 to add and 2 to subtract. So the first two, we're going to say add and simplify. So I got -2 plus 2y added to a 8 plus 3i. So now I'm going to drop parentheses. Now remember, when you're adding with parentheses, you can drop the parentheses and every sign will stay the same. So that this becomes a -2 plus 2y. The 8 is positive, so that becomes a positive 8 plus 3i. So remember, adding, we drop the parentheses. Everybody keeps the sign they had inside the parentheses. And now remember, real adds to real. So the real number is -2 and 8. We would add -2 and 8, which would give us 6. And then we would come in and add the imaginary numbers, which is the 2i and the 3i. When I add 2i plus 3i, I get 5i. Okay? Now, y'all, all of these can be done on the calculator if they're in I form. So let's go to the calculator. Now, remember, on the calculator, when you hit that mode button, it's got to be on A plus BI. So make sure you're on A plus BI, and that is highlighted, okay? All right, so I'm going to start my parentheses. I had -2 plus 2i. To get the I, do you see above this decimal, there's a little blue I? So to get that I, you would hit the blue second button and then that decimal. And that brings you up to I, close parentheses, and then it was plus parentheses, 8 plus 3. Remember, to get the I, I'm going to hit second decimal. Now, y'all, let me go back. I need to fix this. That should have been a parenthesis there. All righty. All right, so let me say I got my -2 plus 2y plus my 8 plus 3i. Then remember, when I done that, we got a 6 plus 5i. So yeah, all of these operations can be done on that calculator, okay? All right, y'all, 12, add and simplify again. I got 9 minus 5i plus 3 minus 4i. So remember, once again, I can drop parentheses and everybody keeps the same sign as they had on the inside. So I got 9 minus 5i plus my 3 minus my 4i. Then we just pair up our like terms and be done. So first I add the real numbers. The 9 plus the 3, that's going to give us a 12. And then our -5i and our -4i. Remember, adding like signs, keep that sign and add those numbers together. So my -5 and -4 will give me a -9i. So notice, we didn't change how they looked when we added them. All we changed is how many we had. All right, so the ones that are going to be a little trickier are going to be to subtract. So these say subtract and simplify. Now, the thing you got to remember about subtraction, you got to distribute the subtraction through the next parentheses. So remember, we must distribute the subtraction through the second parentheses. Okay, so let's try one. We're going to do 13 plus 9i minus 6 plus 6i. So what we mean by distribute the subtraction, we got to treat it like a -1 and multiply everything in the second parentheses. So you would bring down the first parentheses, the 13 plus 9i. So then a negative times a +6 will make that a -6. And then that negative times that +6i will make that a -6i. So the subtraction changes the signs of everybody in the next parentheses when it comes out. Oh, y'all, then it's just what? Add like terms. So we got a 13 and a -6. So 13 plus a -6 is like 13 minus 6, which will give us a 7. And then we got our 9i adding to a -6i. So that'd be like 9 minus 6, which would give me what? A +3i. And y'all, calculator knocks out subtraction also, so let's go play with that. So I had my parentheses, 13 plus 9i. Remember, I is second decimal. Close parentheses. Minus parentheses 6 plus 6i, which is second decimal. Close my parentheses. And notice we get our 7 plus 3i. All right, it had one more subtraction. So this one was a subtract and simplify again. So y'all, I got 11 plus 7i minus 6 plus 5i. All right, so I'm going to distribute that subtraction again. So bring down the first parentheses, 11 plus 7i. Negative times 6 is a negative 6. Negative times a positive 5i is a negative 5i. So once you get it out in parentheses, after distributing that negative, add like terms. So y'all, let's see, our real numbers are 11 and a negative 6, which will give us a positive 5. And then I got the positive 7i and a negative 5i, which will give me a positive 2i. So notice when you add these complex numbers, you get complex number answers usually, okay? All righty, y'all. Next will be multiplication, and it's going to be a little bit trickier. So the thing on the multiplication, if we multiply I times I, we get I squared. Well, y'all, I squared in the long run equals -1. So let me show you that on the calculator. So on my calculator, let me get everything cleared. If I did say second decimal to get an I, and I multiply that by another I times I, watch what it gives me, -1. So if we get I squareds on this, we got to replace them with a -1. And y'all, the rest of these are multiply, okay? So these all say multiply. Now, 15, they're giving it to me as radicals at first. I got a square root of -36 times a square root of a -4. So remember, if you simplify the square root of -36, you would have a 36 and a -1. And then the same thing with the -4, you'd have a 4 times that -1. So inside the parentheses is what I'm doing first before I actually multiply, okay? Because we can simplify inside the parentheses. So notice when I get my first parentheses, square root of 36 is 6. Can't take square root of -1, but I'll replace it with an I. And then the same thing here. Square root of 4 is 2. Can't take the square root of -1, so I'll replace that with an I. But y'all, look what's happening now. Now I can actually multiply because I've done everything I can on the inside. So 6 times 2 is 12. I times I gives me a I squared. But y'all remember, we said I squared equals -1. So this is like 12 times -1, which gives me a final answer of a negative 12. So this I squared's only purpose in life is it changes the sign of the number in front of it. If that number was positive, it'll end up being negative. If this would have been a negative 12 I squared, it would have changed it into a positive 12, okay? So that's the only purpose I squared has, is to change those signs. All right, watch this. I got a 6i times 9 minus 9i. So this is a distributive property. We're going to distribute the 6i times both of those. So 6i times 9 is 54i. And then I got a 6i times a negative 9i. That's a negative 54. I times I is a I squared. Well, we can't do nothing with the 54i, but look here. This 54i squared, remember that I squared equals negative 1. So bring down the 54i. This negative 54 times that negative 1, remember its only purpose is to change that sign. So a negative times a negative will make that a positive 54. Now, although this is the correct answer, we got to put the answer. So put the answer in A plus BI form. That means they like the real number first, followed by the imaginary part. Our real number is the 54, so we're going to bring the 54 down first, and then we'll put our positive 54i. So you always got to have the real number first, y'all, and then the imaginary number second on these, okay? Oh, y'all got any questions yet? All right, so let's keep multiplying then. So that was our distributed property. Now here comes some of our FOILing. 7 plus 5i times negative 5 minus 6i. And y'all, I'll tell you what on these. You can never end up on your final answer with more than 2 parts. You can have an imaginary part and a real part, but you cannot have anything else, okay? So all this stuff will simplify into a real and an imaginary. So remember, foiling. So I'm going to FOIL this. So that means I got to multiply 4 things. So the 7 times negative 5 gives me a negative 35. That 7 times negative 6i gives us a negative 42i. So now let's distribute this. 5i times negative 5 is a negative 25i. And y'all, finally, the 5i times the negative 6i is a negative 30i squared. So when you multiply the I times I, you get the I squared. So remember, I said you can't end up with more than 2 parts. I got 4 at the moment, so let's see what's going to happen. I'm going to add the like terms in the middle. And then I'm going to change this I squared into a negative 1. So remember, that I squared is really a negative 1 sitting at the end of this. So let's bring down this negative 35. Negative 42i and a negative 25i. If we add them together, we get a negative 67i. And y'all, let's see, right at the end, we had a negative 30i squared, which is like a negative 30 times a negative 1, which makes that a positive 30. Well, check this out. Since we turned the negative 30i squared into a positive 30, that positive 30 will now add to that negative 35. So a negative 35 and a positive 30 give me a negative 5 minus my 67i. And y'all remember, we can knock that out on the calculator. So let's go see what we can do on it. All right, so I had parentheses 7 plus 5i. So I want to hit my second decimal for the I. Close parentheses, open parentheses. I had a negative 5 minus 6i. Now, y'all be careful. Use the negative button down here when it's a negative number, but use that subtraction for that middle part, okay? That minus 6i has to use that subtraction key. All right, remember we had two parts when we ended up, and there it is, negative 5 minus 67i. So all these multiplying, that calculator knocked them out quick, okay? Now y'all watch this. 3 plus 8i, 3 minus 8i. These are conjugate pairs. Remember, conjugate pairs look the same. One's being added, one's being subtracted. When we multiply conjugate pairs, we end up with a single real number. So let's write that. Conjugate pairs end up as a single real number. Okay, so let's see this. I'm going to work this whole thing out by foiling it. So I got 3 times 3, which will give me 9. 3 times negative 8i gives me a negative, what, 24i. All right, then we foil the inside. 8i times 3 gives me a positive 24i. And y'all, finally, that 8i times that negative 8i gives me a negative 64i squared. So remember, every time we multiply conjugates in this class, these middle two terms are going to cancel. Negative 24i, positive 24i, those cancel and go away. This I squared, member, equals negative 1. So I'm going to bring down that 9. That negative 64 times that negative 1 makes that a positive 64. And y'all, then we add 9 and 64, we get what, 73. So conjugate pairs like this always 100% end up as a single real number. Okay? Now remember, all these can be done on the calculator with these odds. All right, how about this? 5 plus 7i squared. So this is another one that's foil in disguise. You would write this twice. And then you would foil this. Now remember, these are not conjugate pairs because they're both positive, okay? Conjugate pairs have to have one being added and one being subtracted. So these are not going to cancel out and give me a single real number, okay? But they will give me a complex number, which will have a real part and an imaginary part. So this one we're going to foil all the way out. 5 times 5 is 25. 5 times 7i is a positive 35i. Then you do that 7i times 5, you get another positive 35i. So when you foil the squares like this, the two middle terms always match up. And then y'all at the end, 7i times 7i is a positive 49i squared. So if you notice, these don't cancel, they double, so those are like terms. And then once again, the I squared is going to equal a -1 at the end. I'm going to bring down that 25. 35i plus 35i is going to give us a positive 70i. This positive 49 times the -1 is going to make that a negative 49. So notice you always got that last step of like terms at the end. So let's see, a 25 added to a negative 49. Oh, what's that going to give me? A negative 24. And then bring down your positive 70i. Okay, y'all, so they're not bad. And the very last one we got is the same thing. It is a 6 minus 8i squared. So write that twice. And then we're going to FOIL this. So remember, these are not conjugates because they're both subtracted. So let's see what we get. 6 times 6 is 36. 6 times negative 8i is a negative 48i. Now remember, since this was a binomial squared, the next term will be the same. So that negative 8i times 6 is a negative 48i again. And then here we go. The negative 8i times negative 8i is a positive 64i squared. So you're always going to get an I squared when you multiply the i's times each other, okay? So notice, just like this, when I got my like terms in the middle, and that I squared again will be changed into a -1. So bring down that 36. Ooh, let's see what I got here. Negative 48 and a negative 48 is what, a negative, what's that? 96i. This positive 64 times -1 makes that a negative 64. All right, y'all. So now I got to figure out what is 36 minus 64 equal. And that's giving me a negative 28 minus my 96i. So by hand, that's how you're doing them. Otherwise, punch them on that calculator like they look, and they will give you these answers. Now, remember, the only thing you got to watch out for in Math Lab, they got to have A plus BI form. The real number first, followed by the imaginary part, okay? Y'all, I'll tell you the reason we learned that was so that y'all can do 7.4. In 7.4, some of these equations, we need those imaginary answers because you can't solve them in the real world. And 7.4 is a continuation on when we were solving quadratic equations back in chapter 5, when we were solving them by factoring and stuff. So this is going to give us more ways to solve quadratic equations. So this is solving quadratic equations. Okay, so three ways I'm going to solve these. First way, I'm going to solve by factoring. Second way, I will solve by taking square roots. And y'all, let me tell you the truth. The only ones that I'm going to solve by taking square roots, they cannot have no x term in the middle. That means you'll have the x squared term in a number, but you won't have an x term in the middle on these, okay? The third way I'll solve these, or the ones that I cannot solve by factoring, I will solve by the quadratic formula. Okay. Now remember, the ones that I solve by factoring, they can have two terms or three terms. It don't matter. But the ones I'm going to do the square roots will not have an x term in the middle. And then the ones I cannot factor, I'm going to solve by this quadratic formula, okay? So we might not hit the ones with the quadratic formula today because I'm going to start in the beginning and start with the ones by factoring and taking square roots. We might have to save that quadratic formula till Monday, okay? But maybe I'll be able to introduce that, hopefully. And remember, if I solve by factoring, I want everything on one side equal to 0. So I want them to look like ax squared plus bx plus c equals 0. I want everything on one side equal to 0. When I do the square roots, I want to get it like x squared equals some number. I'm going to get the x squared by itself on one side equal to a number, and then I'll do the square roots, okay? So since the square root stuff is new, I'll show those to you on the steps, okay? So y'all, first one says solve. I got a 7a plus 4 times a 3a minus 9 equal to 0. Now, this problem is just going back over how we solved them by factoring. Remember, when we got them factored into parentheses, we then set each of our parentheses equal to 0. And then we solved each of our little equations. So let's see, on this one, we're going to add 4 first. We're going to subtract 4. So I get my 7a. Those cancel. equal to a -4, and then divide by the 7. So that cancels, giving me a 1a. And then that cannot do nothing to that, so that's going to stay a -4/7. Now my next one, since that's subtraction, I'm going to add 9 to both sides. So my 3a comes down, those cancel, and then I get my 9 over here, and then divide both sides by 3. So those cancel, giving me my 1a, and then 9 divided by 3 is 3. So if they're already factored in parentheses and you got a 0 on the right side, set both factors equal to 0 and get your 2 answers. Now, number 2 has x squared minus 2x minus 35 equal to 0. So I'm happy I got a 0 on the right side. But notice I got a trinomial over here, so we're going to have to try to factor this. So y'all remember that x squared means I got an x and an x. This last sign is negative. Since that's negative, one of my factors is positive. One of my factors is negative. Now I need factors of 35 that subtract to get a 2. So if you look at all your factors of 35, that's 1 and 35, and then 7 and 5. The ones that'll give me a 2 are 7 and 5. Okay? Remember, the larger number has the same sign as the middle. So the 7 has to be negative at that point, and the 5 positive. Now remember, if you add these together, 5 and -7 will give you a -2 like you need, okay? But y'all look at it. I've got 2 sets of parentheses equal to 0. I'm going to do the same thing I did here. I had 2 sets of parentheses equal to 0. So that means I'm going to set each of these factors equal to 0. And remember, at this point, all you're doing is changing signs. So the first one, we would subtract 5. Get a -5. The second one, I would add 7 and get a +7. So remember, x squared means you're going to get 2 answers. All right, now this third one's a little trickier because it's going to have a number in the front. I got a 5x squared minus 22x plus 17 equal to 0. And notice there's no greatest common factor on this because 5 and 22 and 17 don't have nothing in common. So remember, when I did this one, I have to multiply the 5 times 17, which equals 85. I'm then going to find factors of 85 that'll add to get 22. Well, y'all, luckily for me, the 5 and 17 do add to get 22. So we're going to come down. Remember, we started out with our 2 parentheses. I'm going to put an X in front of both. This last number is positive, so both of these factors will be the same sign as the middle. So they're both going to be negative. The factors of 85 that added to get 22 were 5 and 17. But y'all remember, since we borrowed that 5 to multiply by the 17, we got to divide the 5 back out. Now, simplify these if we can. Well, this one, 5 divided by 5 is 1. Remember, on this one, Since it don't simplify, I have to take the 5 and move in front of the x so that I get a 5x minus 17. All this equal to 0. Now, once I got it factored, it looks like the other two, once I had them factored, I'm going to take both of these, set them equal to 0. All right, so the first one, y'all, I'm going to add 1. I get x is a positive 1. On the second one, we're going to add 17 first. So I get my 5x, those cancel, equals 17. And then divide both sides by the 5. So that cancels, giving me my 1x. And y'all, 17 divided by 5, we can't reduce that. So I'm going to keep that 17 over 5. Notice the answers are always opposite of, if this fraction was a negative 17/5, this answer is a positive 17/5. The answers are always opposite in sign in them factors, remember, okay? So y'all, these were just a review of solving the quadratics by factoring like we did in the past. So now let's step into something new. So let me get this paper fixed. So y'all, the new stuff is what we call solving by taking square roots. And remember, to do this, they will have no x term in the middle. You'll just have an x squared term and a number. So the first thing you want to do, you want to get the x squared term on one side by itself. Now, if you got a number in front of that x squared, like say 2x squared or 3x squared, if needed, we want to divide both sides by the number in front of the x squared term. So if it's not a 1x squared, we're going to divide it, okay? After that, once I got that x squared term, we're going to take square roots of both sides. No, because we got a property that says if A equals B, then the square root of A equals the square root of B. It's just letting me know that if I take the square root of one side, I gotta take the square root of the other side. Oh, y'all, once I take that square root, check answers if needed. Also in this section, remember, when I take the square root, I want the positive answers and the negative answers. So we need 2 answers when taking those square roots. So a lot of times I'm going to use the plus or minus. That sort of gives a shorthand. The plus and minus tells me that it can be a positive or a negative number, okay? And I'll tell you what, I like these a lot better than I like factoring because they're a lot quicker. So let's see. These are going to say solve. And y'all, these start at number 4. So I got a 4x squared minus 12 equals 0. So notice there's no x term on this. Okay, so notice there is no x term. So since there's no x term, I'm going to solve it by taking square roots. So I need to get this 4x squared by itself. Remember, that's the first thing it says. Get the square x term by itself. So to move this minus 12, we're going to add 12 to both sides. So that brings down my 4x squared. Those cancel, and that's going to equal a positive 12. Now notice it says, if needed, divide both sides by the number in front of the x squared term. Well, y'all, we do have a number in front of the x squared term, so we need to divide both sides by that number. So bring down the 4x squared, divide by 4. That's going to equal 12 divided by 4. All right, so let's see what that's going to do. Those 4's cancel, giving me my 1x squared. 12 divided by 4 gives me a 3. All right, next it says take square roots of both sides. So I'm going to take the square root of x squared. That's going to equal the square root of 3. And y'all, the square root of x squared, the radical cancels with the exponent. All that's left is the x. Now, here's the thing. We cannot take the square root of 3 and get a number. It does not simplify because it's too small to have any of them perfect squares. But what we got to do is put a plus or minus in front of that square root of 3. Okay, you got to account for the positive and negative numbers from the square root of 3. So if you can't simplify the radical, you still got to have that plus or minus so that it gives you credit for having both of those answers. All right, let's see what I got here. I got 4x squared equals 52. All right, so the x squared term's on one side by itself, but I got a number in front of it, so I need to divide both sides by that 4. So that cancels, giving me my 1x squared like I needed. And y'all, 52 divided by 4. Ooh, let's see what's that's going to give me. That's going to give me 13. All right, the x squared by itself now with a 1 in front. So now we're going to take square roots of both sides. So the square root of x squared gives me my x. And y'all, once again, I cannot pull that 13 out of that radical. And it does not simplify any. But what I got to do in front, put a plus or minus square root of 13. Anytime you get radical answers and you're solving equations, you got to use that plus or minus, okay? Oh, yeah, so that's let's see. I got a couple more doing the square roots to them, so let's see what we get. And I'll let you play with this in a little bit on this number 6. I got a 4x squared plus 28 equals 0. So the first thing I need to do is get this 4x squared by itself. So that plus 28, we're going to subtract 28. So bring down that 4x squared. Those 28s cancel. And that's going to give me what? A negative 28. Now remember my next step, since I got a 4 in front, we're going to divide both sides by the 4. Look, that cancels, giving me my 1x squared. Negative 28 divided by 4 gives me a negative 7. All right, now remember, x squared is by itself. So now I'm going to take square roots of both sides. Let's see what we get. Square root of x squared is an x. So I'm wondering, can I simplify this any? Well, I know the 7 can't be broken down because it's not got factors like 4, 9, and 16. But y'all guess what? That negative does have to come out. So on the side, remember, square root of negative 7 is like a square root of 7 times a square root of negative 1. And that's going to give me a square root of 7 times I. So if it's negative underneath, you got to bring it out as the I. So this will give me my x equals a plus or minus. Now remember, I always put my i's in front of my radicals. So for me, I would probably put an I square root of 7. Notice, you couldn't do nothing with the 7, but you got to bring the negative out as an imaginary number, okay? All right, y'all. X squared plus 64 equals 0. All right, so on this one, I'm just going to subtract 64 from both sides. And look at that. I get my x squared. That cancels. And that's going to equal that negative 64. Now we're going to do our square roots. So the square root of x squared is an x. This is going to be a plus or minus. So y'all, the square root of 64, if you do that on the side, I would make that a 64 and a negative 1. Well, the square root of 64 is 8. Square root of negative 1, I replace with the I. So this answer will be a plus or minus 8I. All right, y'all, how about this? 2c squared equals 18c. But notice, this one has an x term or a c term. Remember, I can only do square roots when it does not have this c term. So since this one has a c term, we need everything on one side equal to 0. So what I'm going to do is subtract that 18c from both sides. So this one is just a tricky one to see what you would do after doing these square root ones, okay? So these are not like terms. So you get a 2c squared minus 18c equal to 0. So if you do not have a x squared term in a number, you got to get everything on one side equal to 0. Now on this one, remember the first thing we look for when we factor is a GCF. And this does have a GCF. Both of these numbers can divide by 2. And then both of them have at least one C in them. So you would factor out the 2C inside parentheses, you would have a C minus, let's see, 18 divided by 2 is what, 9? All equal to 0. So they just threw this one in there to sort of mess with you after doing these square roots, okay? All right, this is factored. Set both of these equal to 0. Well, y'all here, the only thing I can do is divide by 2. So that cancels, giving my C. And 0 divided by 2 is still 0. This one, I would add 9 to both sides. And I get C equals a positive 9. All right, y'all. I'm trying to think here. I think I'll do one more. And then the rest of this I'm going to save for Monday with the quadratic formula stuff. So for 7-4, you'll be able to go at least up to number 9, okay? So number 9, I have a 3y to the third minus 20y squared minus 7y equal to 0. Yeah, so that'll give us just a few to deal with the quad formula. If I got time, I'm going to introduce it real quick, though. All right, y'all. So the first thing, I do have all these terms here, but look what they all got in them. They all got a y in them. So we're going to factor out a y, and that's going to put a 3y squared minus 20y minus 7 all equal to 0. So since they all had a y in them, I took one y out from everybody. Now remember, this is a y cubed. This means I better get 3 answers for this, okay? Now we got this part taken care of. So now we got to factor what's inside the parentheses. And y'all, since the 3 didn't factor out, remember I'm going to do 3 times 7, which gives me 21. So let me bring this first y down. And we know these will factor into parentheses. Y squared is a y and a y. Last sign's negative, so one's positive, one's negative. And I want factors of this 21 that'll subtract and get 20. Well, now that'll be what? 21 and 1. Larger number, same sign as the middle. So the 21 is negative and the 1 is positive. Now, since I brought that 3 to get to 21, I'm going to divide that 3 out. So y'all bring this y down. This one does not simplify, so I'm going to put the 3 in front of the y and make that a 3y plus 1. But y'all, this one will simplify, so I get a y minus 21 divided by 3 is 7. All right, so let's get those 3 numbers. Set this one equal to 0, and that one's done. So my first answer is 0. Set the 3y plus 1 equal to 0. Subtract 1 first. So I get 3y equals negative 1. Then come and divide by 3. So those cancel. I get 1y equals a negative 1/3. And then set my last factor equal to 0. And on that one, all I got to do is add 7 to both sides and get my third answer. Oh, y'all, so remember, y cubes get 3 answers. Squares get 2 answers. The highest exponent always tells you how many answers you're going to get on these problems. All right, y'all. So let me see. So, y'all, let me introduce y'all to the quadratic formula. I use this for equations of the form ax squared plus bx plus c equals 0. You want everything on one side in descending order equal to 0. But when you cannot factor them, your solutions can be given by the following formula. Y'all probably seen this in life before, but the quadratic formula is negative b plus or minus the square root b squared minus 4ac, all of that over 2 times a. A is the number in front of the x squared, b is the number in front of the x term, c is the number at the end. We'll plug those numbers in and solve this to get our answers. Now, most of the work is going to be under this little radical part, okay? And remember, when we deal with radicals, that's what this plus or minus for. It can come out positive for one answer, and then if it comes out negative, I get my second answer. So I'm going to show you one of these before we end tonight, and then let's see, we come back, Tuesday? I will go over these more, and then we'll start studying for that final exam. So I'm just going to do one of these. Use the quadratic formula to find the exact solutions. All right, so I got it. X squared minus 8x equals 20. So y'all, the first thing, remember, I got to have a 0 on the right side. So that 20 needs to be 0. So to turn that into a 0, I need to subtract 20 from both sides. Now, there's no like terms over here, so I'm just going to put them in order. My x squared term, my x, and then my number. So I'm going to have my x squared minus that 8x minus that 20, all of that equal to 0. All righty. So let's see. Now we got to figure out A, B, and C. Well, remember, if there's no number in front of the x squared, we treat it like a 1. So that means A is 1, B will be that negative 8, and then C will be a negative 20. So I know my 3 numbers. Now I'm going to plug them into my formula. So x equals a negative times a negative 8. So y'all, that negative is always in the formula. So what's going to happen when I put a negative 8 into the formula behind that negative? These 2 negatives are going to make that thing positive in a second. All right, plus or minus my square root. B squared will be negative 8 squared. If you're doing it on a calculator, put that negative 8 in parentheses, because a negative times a negative is going to make that positive in a second. All right, minus 4 times A, which is 1, and C, which is a negative 20. all of that over 2 times a, which is 1. So notice, most of my work's under here. So a negative times a negative 8 makes that a positive 8. So whatever your sign is up here of your B, that negative in the formula is going to change it to the opposite. All right, now let's see what happens under here. Negative 8 squared is negative 8 times negative 8, which is a positive 64. And y'all, right here, everything over here is being multiplied. You got a -4 and a -20. You got 2 negatives. That end is going to become positive. 4 times 1 is 4, times 20 is 80. All of that over 2 times 1, which is 2. All right, so I can still work under my radical. So I'm going to bring down my 8 plus or minus square root. 64 plus 80 gives me 144. All of that over 2. All right, y'all. Bring down that 8 plus or minus. Now it's time to actually see if we can take the square root of that 144. Now, if the number's not a perfect square like this, then we would have to try to simplify it. So some of those Monday, we might have to simplify a little bit. But y'all, 144 is a perfect square. And the square root of 144 is 12. All of that over 2. Now, all 3 of these numbers will divide by 2. So you got to divide both the outside numbers by that 2. So 8 divided by 2 gives me a 4. Plus or minus 12 divided by 2 is 6. Now, here's how you get your first answer. The first answer, we do 4 plus 6, which will give me a 10. My second answer, I do 4 minus 6, which gives us a -2. So the plus or minus that was in front of that square root is what we use to get the 2 separate answers. We add first, and then we come back and subtract. So, y'all, this is just a preview of the quadratic formula. Come Tuesday, I'm going to knock out the rest of these, and then it's going to be time to study for our final exam, okay? All right, y'all, questions over that? So remember the I stuff, we had to learn the I stuff because what if this was a -144 under here? Then I would get imaginary answers on this, okay? So we can only factor real numbers. Square roots, I can get real numbers or imaginary. Quadratic formula, I can get real numbers or imaginary, okay? So we'll play with that a little bit. That's the last thing I'm going over in this class. So after I do a few examples of this, I'm going to show you what to study for your final exam on Tuesday, okay? All right, y'all, so let me stop that share. All right, y'all, so any questions?